I want you to think about the last time you were in a forest after a recent rain. You take in a deep breath, and you smell that deep, earthy smell of the soil. That is geosmin, a microbially produced gas. If you decided to hike through that forest, maybe you ended up at the top of a mountain in the Blue Ridge of Appalachia. As you gazed at that beautiful cerulean haze blanketing the mountaintops, you were seeing isoprene, a plant-produced gas. Every minute of every day, dozens of these gases are released into the environment during the decomposition of plant material. I study how these gases can be used to keep soil healthy in order to increase agricultural production. We're going to need to produce twice as much food by 2050 in order to keep up with our growing population. Healthy soils are rich in organic matter. You might say that organic matter is what plants crave. It serves as the pantry for crops, providing a stockpile of water and nutrients for when the plants need them. Therefore, building soil organic matter is key to meeting increased demand for food. So if we want to grow more food to feed more people, we have to make sure that our plants have all the water and nutrients they need. We can do this by building a bigger pantry. So simply put, if we can increase organic matter, then the crops have a bigger pantry to feed them throughout the growing season. However, we don't have a great understanding of how to increase organic matter in the soil. So I started out with a pretty simple question. Can those gases that we smell and see in forests be used as the building blocks for expanding the amount of organic matter in soils? But there's a catch. There's always a catch. You can't just pick up a handful of soil and tell where all the gases went. If you were building a pantry in your home, you could track where each board goes by labeling them. I figured I could do the same thing, but instead of using a Sharpie, I labeled the gases using a heavy version of carbon that isn't very common in nature. This allowed me to simply measure the mass of the carbon in the different parts of the soil, and if that carbon was heavy, I knew the gases had been there. I found that these gases that are released when leaves are decomposing enter the soil where native bacteria and fungi gobble them up. When those bacteria and fungi die, they release their cellular contents into the soil, increasing organic matter, thus making the pantry bigger. This study was the first time anyone showed that plant-derived carbon could enter below-ground ecosystems without direct contact with the soil, and it established that these gases not only enrich our experiences in nature by providing us with comforting smells and beautiful sights, but that with proper management, these gases can be used to build a bigger pantry for our crops, allowing us to grow more food and helping us feed the growing population.